With the dimension 100 to 100 centimeter. Local coordinates GCP touches were measured and converted into geodetic coordinates using GNS with accuracy 3 millimeter. Above Pix4D tagger and values GCP in the UAV imagery because accurate Soviet ground control points are used to give reference orthomosaics. And fight link and GCP. These are 28 images from flight clinic. And after these steps, we used Pix4D mapper software for photometric data processing. Starts with the determination of the geothermal flight information and camera parameters for each recorded image during the image acquisition. Geothermal steps add geographic location to each image. These steps follow the determination of the interior and exterior parameters of the image in the photogrammetry. The measured coordinate of the GCP is used in camera calibration to the geometric calibration parameters, including the position of principal point and focal length, radial distortion, and tangential distortion parameters. 3D point cloud generation is the next step with dense image meshing algorithm to reconstruct 3D model. All these steps can be accomplished by fully automated process with available commercial software tools. In this study, 4 software packages were employed for image acquisition, Pix4D capture, GCP on image automatically capturing, Pixtagger, 3D point cloud generation, Pixmapper, and solid model Autodesk. Generally, automatic data processing, initial processing, automatic error triangulation, key-point extraction and matching, tie-point building, and computing matches, camera calibration or optimization, point cloud and mesh generation, dense meshing, point cloud, surface reconstruction, dense meshing, segmentation, fixed coordinates, and exporting 3D mesh. Third steps, then and DSME orthomosaic generation, color point cloud, orthomosaic, and orthocolor graded DSM generation. And finally, 3D solid model generation, solid model and these tie points and meshing, calibration. This 3D mesh generation. And is the first step, the orthomosaic generation. Left digital elevation model and the others, digital surface models. This generative model orthomosaic generation. First, at the left, ortho image from perspective and above images, captures images. magic as orta imaj. And, 3D is a 3D model. Photometric software combines information from multiple image taken from both overhead and side or facet to create the 3D models. But our study only one position captured image is a fish eye lens, both from overhead and side and facade images. And 3D model improves the Autodesk software. We used different methods in this study. In the case, the way we get dynamic SLM, simultaneous localization and mapping, and PPK, post-process kinematic with JNS, Linux data that will store achieve high accuracy for determination of the geotechnic flight information and camera parameters for each recorded image. The internal camera accuracy check was performed using fixed coordinator software package and reached results were better than expected accuracy exceeded coordinates. The very dense point cloud of study area was produced with the average density of 791 points per meter cube, including the dense points of facades of the all-time mine. They recorded 28 another image with fish eye lens successfully calibrated, used for complete the 3D modeling of the architectural heritage, include terrain, trees, and historical buildings, facades, and roofs. And we were successfully generated with low-cost or UV fish eye lens. And accuracy assessment. First, general quality check image approximately 33,000 K points improved, and all images calibrated and optimization. Common optimization statistic and matching all calibrated image and georeferencing all DCPs at RMS error 0. This one, the DCP checkpoint, check and checkpoint set, we improved two different calculation. First, with two checkpoint. Second, all we use all GSBs, and the result is nearly 0 millimeter. And second steps, compression of exterior orientation parameters. Also, 6 elements of the EO parameters is nearly 0 accuracy. Third step, point-to-plane test analysis. It's for future study. And conclusion. In this study, the performance of the Dorcas 3D solar rotary quadcopter UAV equipped with GoPro action camera fisheye lens mounted, very stabilized gimbals. Solar smart control was tested for digital documentation autonomy as an architectural heritage in Davutpaşa study area. The small double grid image block is, which consists of 20 nether image, including 3 flight strips with 20% in flight direction and 80% side left, was planned and performed on 6 April 2017. The photogrammetric data processing have been conducted using Pix4D software image for 3D point cloud, DCM and automatic generation, and Autodesk Recap for 3D solid model generation. All the recorded nether image with fisheye lens successfully calibrated used for complete 3D of the architectural heritage documentation. The 3D point cloud, including the point on terrain, trees, historical buildings, facades, and roof, was successfully generated, as well as DCM automatic and 3D solid model of the Otay mine located at Davutpaşa campus.